All right, we are continuing on with our review. So right now we're going to do some grade 9 and some grade 10 review. Really important though, Bohr-Rutherford diagrams, they never go away. So you're going to be looking at Bohr-Rutherford diagrams. This year we're also going to be using Lewis diagrams as well too. It's a really great shortcut. So if you were not taught Lewis diagrams in grade 9 or grade 10, I know we started them in grade 9. That is okay. You just want to make sure you tune in for the second half of the video, because I promise you it is going to make your life much, much easier in the coming couple of days. So just a reminder of what a Bohr-Rutherford diagram is. A Bohr-Rutherford diagram shows us where things are in the atom. So essentially it shows the location of the electrons, the protons, and the neutrons. Remember that the protons and the neutrons are located in the nucleus, and the electrons are orbiting on the outside. To figure out the number of protons, you want to look no further than the atomic number. The atomic number is the small number in the upper part of your periodic table. So for example, the atomic number for lithium is 3. On the periodic table you've been given, it also does have that legend. So if you're ever not sure, double check the legend to make sure you're looking at the atomic number. The atomic number doesn't have a decimal, it is the exact number of protons. The number of electrons, we're going to be looking at atoms for now. We're going to talk about ions in a little bit. So when we're looking at atoms, atoms are considered to be neutral. Since atoms are considered to be neutral, that means the number of electrons and protons are going to be equal. The number of positives equals the numbers of electrons. Lastly, we have our number of neutrons. Neutrons do exist in the nucleus as well too. They have no charge. They do have a mass though. So in order to figure out how many neutrons are in the nucleus, you want to take the mass number. The mass number is the total number of protons and neutrons, and you want to subtract the atomic number. Remember, the atomic number is the number of protons. So essentially, you're figuring out the number of neutrons by taking the total mass, and you're subtracting the atomic number. Just a reminder where the mass number is. The mass number might vary. Typically, it's at the bottom of the periodic table. Sometimes it can be in the upper right-hand corner, though. The mass number now in grade 11 is going to have decimals. So if you didn't see a mass number with decimals in grade 9 or 10, you've now got a mass number with decimals. We'll talk about that more when we talk about isotopes. So this is just kind of an overview on how to do Bohr-Rutherford diagrams. I learned more through doing, so this is just going to be for those of you that really like lists. So the first thing you want to do is you want to calculate the number of protons, neutrons, and electrons. You don't want to be mid Bohr-Rutherford diagram trying to do math in your head. So you're always going to calculate your number of protons, electrons, and neutrons first. You're going to draw the nucleus, and all you have to do to draw the nucleus is you are going to write the symbol of the element, and you're going to tell me how many protons and how many neutrons right underneath. The symbol of the element can be found on the periodic table, and remember the two subatomic particles found in the nucleus is the number of protons and the number of neutrons. Then you're going to place the electrons in their orbit. Just a couple of rules around that. Just a reminder, the number of electrons in the orbit, there are maximums. So you can fit 2 electrons in the first orbit, 8 in the second, 8 in the third. You always want to fill the lower orbits first. So you have to start on the first shell, fill the first shell. If that's filled, go to the second shell, go to the third. Just a reminder, the first shell can hold 2 electrons. Everything else can hold 8, and these rules actually only apply to number 20, but you can really only draw really good Bohr-Rutherford diagrams up until the element 20. It's a limitation of the model. I'm going to talk about that more in our atomic theory lesson, and then I'm going to teach you a brand new way to draw atoms when you get to grade 12 chemistry. So let's show you how to draw some of these elements. I'm going to go ahead, I'm going to close the camera down so I can actually write and you're not looking directly at my nose. So let's go ahead and we are going to draw ourselves a Bohr-Rutherford diagram of helium. So first of all, I want to look at the periodic table, and based on the periodic table, I want to figure out the number of protons, the number of electrons, and the number of neutrons for helium. If I look at the periodic table, I'm going to see the atomic number for helium is 2. So that means I have 2 protons and I have 2 electrons. My mass number is 4. So to figure out my number of neutrons, I'm going to take 4, my mass, subtract 2, my atomic number. That's going to tell me I also have 2 neutrons. So now I'm ready to draw. To draw, I'm going to go ahead and I'm going to place my symbol in the middle and tell the number of protons and the number of neutrons. Protons is 2, neutrons is 2. Then I'm going to go ahead and I'm going to draw my first shell. You don't need a circle around that symbol to tell me that's the nucleus. You can just go ahead and you can draw your first shell. And then on this first shell can hold up to 2 electrons. Well, we're looking to place 2 electrons. So that's perfect. There's actually 2 different ways that you can place it. One way that you might have been taught in grade 9 or 10, you might have been taught to place your electrons like this in the first shell. That's totally fine. That's okay now. In grade 12, I'm going to teach you a new way. Or you might have been taught to place your electrons, your first 2 electrons side by side. That's also totally fine. That's actually more accurate, and I'll tell you why in grade 12. Now we're going to take a look at nitrogen. So nitrogen, again, I want to figure out the number of protons, the number of electrons, and the number of neutrons. If I look at the atomic number of nitrogen, it's 7. So that tells me 7 protons, 7 electrons. And if I look at the mass for nitrogen, it's 14. 14 minus 7 is also going to give me 7. I start with a symbol in the middle. I state the number of protons, number of neutrons. Both are 7. I'm then going to go ahead and I'm going to place my electrons on my first shell. Now I have 7 electrons total to place. I've only placed 2. That leaves me with 5 electrons remaining to place on the next shell. So on the next shell, there's one of 2 ways that you can actually start placing your electrons. The way you were probably taught in grade 9 is top, side, bottom, side. Now notice that I didn't pair any of my electrons. I haven't paired any of my electrons yet. The reason I didn't do that is because we have to fill all sides first. Once all sides are filled, I can go ahead and I can place an electron here. The other way that you can do it, that you might have been taught, you're going to end up with the same answer. So it's kind of the same thing. It's just a more accurate way of placing them. You can pair your first 2 electrons, but your first 2 electrons only. You can only pair your first 2 electrons. After that, I have to go top, bottom. Oh, don't crash again. Don't do it. Nope, we're good. And side. Last one, boron. Now would actually be a great chance to go ahead and pause the video and maybe try this one on your own. I'm going to trust that you did that. I'm just going to go ahead and take it up with myself. I'm talking to myself here. So boron, you want to calculate the number of protons, electrons, and neutrons. My atomic number is 5. So I have 5 protons. I have 5 electrons. And if I look at my mass number is actually 11. So 11 minus 5 is going to give me 6 neutrons. Ooh, some variety. So number of protons equals 5. Number of neutrons equals 6. My first shell can fit 2. That's going to leave me with 3 on my next shell. Now again, 2 correct ways to do this. I could go top, side, bottom. That is totally correct in the grade 11 world. We're okay with that. Or if you want, you can pair your first 2 electrons and only your first 2 electrons. Go to the side. That is also correct in grade 11. Now let's talk about Lewis diagrams. So this might be review for some of you. This might be new for some of you. Lewis diagrams are what we're going to start learning in grade 11. So Lewis diagrams, we're going to find that only the outer electrons, we call those valence electrons, are involved in bonding. So we actually really, when we talk about bonding, which is a theme for this unit, we actually only care about our outside electrons, our valence electrons. So Lewis diagrams are a simple way for us to understand how electrons form chemical compounds. So it's not going to show us the number of protons. It's not going to show us the number of neutrons. It's just going to show us the outside number of electrons, and that's going to help us to understand bonding. It's just a nice little shortcut. So for Lewis diagrams, you're going to write the element symbol. You're not going to have to use positives. You're not going to have to use neutrons. I don't care about any of those. I just want to know the element symbol for the nucleus. Around that element symbol, I'm going to draw dots, 1 for each valence electrons. The dots are going to be spread over 4 sides, so I'm not going to have a ring this time. I'm going to have more of what I call an invisible box. The dots are going to be spread over 4 sides, and you don't pair until all sides have at least one dot. Now, just a reminder of how to figure out the number of valence electrons. You could do it the long way. You could draw a Bohr-Rutherford diagram first, and then you could count the number of electrons on the outside. Or you could remember the useful hack that column 1 has 1 valence electron, column 2 has 2 valence electrons, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and column 18 has 8 valence electrons. So you were taught that in grade 9 and 10, and we also reviewed that in the periodic table video. So you might want to go ahead and pause the video now and maybe record that at the top of your periodic table. So let's go ahead and let's draw some Lewis diagrams. So to draw the Lewis diagram of oxygen, I want to start with a nice big O in the middle. That O, again, represents the chemical symbol. We don't have to draw the number of protons. We don't have to draw the number of neutrons. The O is sufficient. I then want to go ahead and I want to figure out how many valence electrons oxygen has. To do that, I want to find its group number. Its group number is 16 on the periodic table. That means oxygen has 6 valence electrons. So I'm going to go ahead and I'm going to place 1 electron on each side. So it's going to look like this. 1, 2, 3, 4. Once I have 1 electron on each side, I can start pairing. 5, 6. That is it. Isn't that lovely? That's so much nicer than a Bohr-Rutherford diagram. And that's actually got all the information that we need for grade 11 chemistry. Now, you could have started with that nice little trick that I taught you before. You could have started pairing only your first 2 electrons, 1, 2, and then spread the rest over the sides, 3, 4, 5, 6. Notice we get the same answer. So it doesn't matter. It's just a different way of filling that's more accurate based on the grade 12 model. Let's go ahead and let's try neon. So neon is located in the 18th column. The 18th column means that I have 8 valence electrons. I'm full. So my symbol for neon, Ne, and I'm going to go 1, 2, 3, 4. Missed there a little bit. Oh no, I'm frozen. 4. Let's just leave that dot. That looks fine. You guys know that's a dot, right? 5, 6. It's getting sketchier. 7, 8. That was a struggle, but you can see what I mean, right? There we go. That's okay. So I recommend now going ahead, pausing the video, and trying the last one yourself. You're back, so you either did it or you just want me to do it. If you take a look at sodium, the chemical symbol for sodium is Na. Sodium is in the first group on the periodic table, so sodium has only 1 valence electron. Isn't that lovely than having to draw on all 3 rings? And this tells me all the information that I need for sodium. You are now experts in Bohr-Rutherford diagrams. You are now experts in Lewis diagrams. So next up, we're going to be doing a review again. We're going to remind you how to form ions.